Router paths and packet switching. Step 2. In computer networks, the process of delivering data from one device to another involves a combination of packet switching and routing decisions. At the heart of this process lies the router, a device that not only receives incoming frames but also determines the best path to forward them toward their final destination. Step 2 of this process focuses on how router R1 handles an Ethernet frame after receiving it. When R1 receives an Ethernet frame, the first action it performs is to check whether the destination MAC address of the frame matches its own interface MAC address. If there is a match, R1 accepts the frame, otherwise it discards it. Once verified, R1 strips off the Ethernet header and examines the destination IP address inside the packet. This IP address plays a critical role in determining the forwarding path. At this stage, R1 consults its routing table, which contains network entries, next hop IP addresses, and the corresponding exit interfaces. If the destination IP address is found in the routing table, R1 identifies the next hop IP address. Using its ARP cache, the router then matches this next hop IP to the appropriate MAC address. With this information, R1 re-encapsulates the packet into a new Ethernet frame, updating both the source and destination MAC addresses. The new Ethernet frame is then transmitted through the appropriate exit interface, in this case, Fast Ethernet 0/1, Phase 0/1. Here, a packet originates from PC1 192.168.1.10 with a destination IP of 192.168.4.10, which belongs to PC2 on another network. As the packet arrives at R1, the router verifies its headers and consults the routing table. Since the destination IP belongs to a remote network 192.168.4.0/24, R1 identifies the next hop as 192.168.2.2, an interface belonging to router R2. Using ARP, R1 finds that the MAC address of 192.168.2.2 is 0B-31. Consequently, R1 builds a new Ethernet frame with destination MAC 0B-31, and the packet is forwarded out of Phase 0/1 toward R2.